everyone. Today we will talk about what is it like to be a machine learning quality assurance engineer, what is our daily work focusing on, what are the challenges we face, and what is the difference between being a quality assurance engineer and working in the machine learning field as such. So, who am I? My name is Hristina Nedyalkova. I have about 7 years of QA experience working in bankings, e-commerce, and insurance industries. And for the last 2 years, I moved to the machine learning field, being a QA. I graduated both in business and computing departments at the American College of Thessaloniki. And what I love the most about being a machine learning QA is focusing on corner case scenarios while testing the models. So let's talk about what machine learning is first and get the understanding. So it's a subfield of artificial intelligence. What we do is create a program that is able to learn something without explicitly telling the computer what to do. Then the machine learning is basically the ability of the computer to replicate human behavior. We identify the problem, we break it down into concrete steps, and then we try to solve it. We teach the computer how to do it, how to solve the problem, and the computer then is able to learn and actually repeat these steps. And as you can see, when a machine learning walks into a bar and the bartender asks the algorithm, what would you like to drink? The algorithm literally replicates the human behavior and says, yeah, what everyone else is having. There are a couple of different machine learning types, and now we will focus on one of them, and this is the supervised learning. What the supervised learning is basically you provide the data to the model, you supervise how to learn it, saying what is it like, and then you create the predictive model. Once you supply the predictive model with data, the model is able to automatically, in our case, classify the image. So what we can see here on the picture, we have a couple of images. These are ducks and then not ducks. And we would like to get a classification algorithm and predictive model at the very end. So we say which animal is a duck and which is not. Then we perform the supervised learning step and we get the result, which is a predictive model, which can classify the images as being ducks or not ducks. And at the last step, we provide an image of a duck to the predictive model that the model hasn't seen before, and then the model classifies it. In our case, this is a duck. And if we supply a different image, for example, of a tiger, the expected result would be that the predictive model would say the tiger is not a duck, because this is what we taught the model. So as you have the bigger picture now, let's focus on the quality aspects of machine learning. So leaving aside the general QA rules we follow, there are two major aspects of quality assurance in machine learning. These are data and models. And under data, we observe like allocating relevant data, performing some steps to get it into right shape, and prepare testing data as well. It's important to differentiate between training and testing data, though both are like integral to improving and validating the machine learning models. Whereas like training data teaches the algorithm to recognize patterns in the dataset, testing data is used to assess more the model accuracy. Then we need to train the model and perform model evaluation in order to ensure a certain degree of quality. And this goes hand by hand with some major challenges, of course. And what's important for me to mention is that Machine learning is equal parts data and machine learning. So we divide it 50-50 in our case. Let's move to the first step, finding data. You can see here we have lots and lots of data. And of course, we cannot just go and use it directly. We have to steer the big piles of data and select the most representative and relevant examples. So depending on the problem we try to solve, we determine the best use case scenarios. Gathering data includes getting access to the raw data, choosing the important attributes of the data, what would be the good indicators, and then the outcome we want our machine learning model to predict. This is an important step because the quality and the quantity of the data we gather determines how good our predictive model would be. The next step would be to clean, prepare, and manipulate the training data. So assessing and improving data quality is the next step of any machine learning model project. This includes checking the following aspects that I have listed. So these are consistency, accuracy, compatibility, completeness, timeliness, and duplicates, or so-called corrupted records, which we definitely want to remove. Preparing the data means loading it into a suitable place, getting it ready to be used in machine learning training, assessing the quality, following the aspects that I have listed, and then we deliver this outcome to our machine learning teams. So as stated in the picture, garbage in, garbage out. If you give garbage to your machine learning model, this is what we come out. This is why we definitely want to focus on the quality of the data and perform all these steps in order to get clean and high quality training data. The next step is the so-called data labeling. So what we do is we label the data, and how we do it, we draw bounding boxes around the data that we would like to extract. Labeled data is annotated to show the target, which is the outcome you want your machine learning model to predict. Like data labeling is sometimes called either data tagging, annotation, moderation, transcription, or processing. There are various data labeling types. So the process of data labeling invoices is marking the dataset with key features that will help train the algorithm. What is important is that we perform data analysis, or this is more like looking for a pattern in the documents, getting the context, and getting like common fields that we would like to extract. After we perform the data analysis, we prepare the annotation guide or particular steps and data that we would like to extract. We work with external vendors who perform the annotation steps or the data labeling steps. When these are done, they deliver the data set to us, and we perform automated checks, which are built in-house, or manual checks, which compose of getting a sample of the data, which can be 10 to 20%, depending on the use case scenario, performing some checks, and then statistically calculating what's the error percentage. Depending on the final result, we either decide to iterate again on the dataset, bringing higher quality, which means checking more samples, correcting them either manually or automatically, depending on the use case scenario, and then getting the expected percentage errors, which is acceptable by the machine learning teams. And of course, this is also like the biggest challenge for us, how we can assess big piles of data. So for example, if we have 1,000 of documents, it would be quite time consuming to correct all of them. This is why we first take a sample, and depending on the result, we decide on next steps and on the acceptable percentage error, which will be calculated at the very end. After we have the particular steps, we would like to get systematic approach to data quality. And this is what we focus on. So set of assessment steps that we should follow. We design a way for the implementation so that these steps can map the assessment based on the selected dimensions to the actual data. For instance, the following 5 requirements are used. So the first one is time frame. What this means is that we decide on an interval for when the investigative data is prepared, collected, and steered properly. Then the next step is the definition. We define a standard on how to differentiate the good from the bad data. Then how to quantify the data for the assessment, or this is the aggregation step. The fourth one is interpretability, or this is the mathematical expression on how to assess the data, decide on the statistical calculation of errors, and what's the acceptable percentage. The last one is the threshold, or this is when we have to cut off and decide to stop, evaluate the final results, and decide whether we are satisfied with the results or not, and what would be next steps. After this, we focus on model evaluation and optimization. So the primary goal of supervised machine learning is to accurately predict the data that we supply. We want our model to be as accurate as possible, and when predicting the new data for which the target variable is often unknown, like said in a different way, we want our models, which have been built from some training data, to generalize well to new data. That way, when we deploy the model in production, we can ensure that the predictions generated are of high quality. Therefore, when we evaluate the performance of the model, we want to determine how well that model will perform on new data. So there are 3 steps we focus on while performing model evaluation. First, we check a sample output and ensure it aligns with the expectations. Then we observe the accuracy and the projected automation. So let's define what accuracy is. This is the percentage of correct predictions for the test data. It can be calculated easily by dividing the number of correct predictions over the number of total predictions. The accuracy of the automation represents its ability to produce correct results, specifically results as close as possible to the user's needs. We select the desired accuracy and verify that the expected automation rate is reached. In case it is not, we start looking for some systematic errors in order to be able to identify the potential issues. What a systematic error is, it's not determined by the chance, but it's introduced by an inaccuracy as of observation of measurement inherited in the system. So let's see an example of a systematic error. In our case, this is an example of offset, which is a type of systematic error. Here, the instrument isn't set to 0 when you start weighting the items. So, for example, we can observe a kitchen scale, let's say, including a tare button. And this sets the scale and container to 0 before contents are placed into the scale. So in our case, the offset of the weight is about 1 kilogram. So every product you weight on the tare will be with offset of 1 kilogram. And this is a systematic error example. The next step is the model optimization. So sometimes we need to perform optimizations in order to achieve better results. Model optimization is similar to data quality iterations we mentioned earlier. So if on the first round we do not encounter, for example, high quality, we do second or third round of iterations in order to achieve the desired quality. And this is similar to the model optimization. If we observe poor model performance, we first focus on the data and inspect the labeled data. In case we notice some systematic errors, we would correct automatically or manually, depending on the use case. And then once we have the corrections in place, we can retrain the model and then evaluate it again and observe the final results. After we have model improvement and we have performed the model evaluation, we can also compare it to the older model, observe the results again. And once we achieve the expected accuracy, we can deploy the model and observe the predictions of the model. So besides the data and the model quality inspections that we do, the work of a machine learning quality assurance engineer includes also the demonstration of the products. And what can go wrong with a demo? Well, everything literally can go wrong with a demo. As I mentioned several times, data is the key. And as you can see, we're always there to put out fires during customers' demo. So often, our sales, for example, teams come to us with issues around the demo. And what is difficult for them is to spot systematic errors and poor model performance as well, and reasons for the poor model performance. This is where we come in place, and we have to quickly react, spot the systematic errors, either correct the data, retrain the model, and deliver high quality results very quickly. Through our experience, a lot of documents that we have observed, we are able to do this very quickly, spot the poor quality gaps, and then improve the performance. At the very end, like the model evaluation takes place, and we verify that the accuracy and automation is reached. And now, what profile makes a successful QA? Where we focus on quality assurance engineers with experience and people who have analytical thinking. And according to us, these are like the important parts of being a successful machine learning quality assurance engineer. What is the difference between being a quality assurance engineer in other industries is that, as we mentioned, we focus on the following, like data validation, evaluation. Then we observe the model performance, we evaluate it. We work closely with the other QA teams to ensure the integration of the models with the applications that we support. And last, but of course, the most important is to focus on finding systematic errors, which is the key to improving both data and models. Thank you very much. And these are my contacts. Please let me know if you have any questions. Thank you.